Dr. Esther Trufan, and in this video, I'm going to demonstrate the titration of a diprotic weak acid, in our case, maleic acid. I'm going to use a 0.05 molar maleic acid solution. This concentration is approximate, so based on our standardized sodium hydroxide concentration, we will be able to determine a better concentration for our maleic acid solution. For the titration, the first thing that we're going to need is a burette on a burette clamp that is attached to a stand. And we have done this experiment before, so I will demonstrate how the setup looks like. On the one side, I have the burette that is charged with my sodium hydroxide solution, the burette clamp, and I have a separate clamp that I will use to attach my pH probe to it. Speaking of which, we need a pH probe. And today we will be using the Vernier wireless pH probe. It is currently sitting in a buffer storage solution, but we will need to rinse it with water and wipe it with Kim wipes before we can insert it into our beaker. To perform the titration, we're going to use magnetic stirring, so we will need a magnetic stir plate. This only does stirring, and I will use it here. The setting for the stirring should be on low to medium, but definitely not on high, to avoid any kind of harm to the pH probe. For our experiment today, we will be using a 0.05 molar maleic acid solution, of which we're going to measure out 25 milliliters, approximately 25 milliliters, with a 50 milliliter graduated cylinder. And we will be doing the titration inside a 150 milliliter beaker that is equipped with a magnetic stir bar that is already inside. To monitor the changes in pH, we are going to use the universal indicator. And to monitor the pH via the wireless pH sensor, we will be using our connection to a device on which the graphical analyzer should already be pre-installed. So to get the experiment started, the first thing that we're going to do is measure out approximately 25 milliliters of our maleic acid. It is okay if it's a little more or a little less, but it is important that we record the volume by looking at it at the meniscus. I have 26.1 milliliters of maleic acid. I will transfer this into my beaker. And with that, I am done with the graduated cylinder. Next, I am going to turn on the stirring so that I can locate where the magnetic stir bar wants to stir naturally. If it's not where I want it to be, this is a good time to adjust things because the pH probe is not harmed because it's not there yet. So it is rotating at between 12 and 3 on the clock. So I need to place my pH probe opposite side of that on this clamp. To set my pH probe, I will slowly release the pressure on this cap, extract it gently, move it above my waste container, grab a squirt bottle with deionized water, and rinse it thoroughly. Once it is thoroughly rinsed, I will take a Kim wipe and I will dry it. Then, because the pH probe should not be left outside for very long, I will slide it inside my solution and tighten the clamp so that it stays in a stable, steady position, but not enough to accidentally break it. So at this point, my solution is ready. All it needs is the indicator. And I will add approximately 4 drops of the universal indicator. And I'm using universal indicator because the color change provides the fastest response to any pH changes. If the color changes, that usually means I need to be more patient as I wait for the pH probe to eventually reach that final pH at that stage. With all my materials already in our setup, I am ready to begin the titration. For every part of this titration, we need to collect the volume of the sodium hydroxide solution in the burette, and we need to collect the pH of the solution through the wireless pH probe. Just like every other time, when we are recording the volume, we're going to lower the burette to our eye level so that the meniscus of the sodium hydroxide solution is legible and we're not making mistakes in our readings. If we are vertically challenged like I am, then that will require some maneuvering. We can rotate our burette clamp, move our station to the edge of the bench top, and then slide it down so that we can have our meniscus at eye level. And then we're going to read the volume, which in our case, for the starting volume, we have 0.39 milliliters. We may need to do some maneuvering at the beginning, but as the level of the solution continues to go down, it should become easier and easier to read these volume measurements. Our starting pH of the maleic acid solution is 1.70. And we're going to start with small additions of approximately 2 to 3 milliliters of sodium hydroxide. When there is a drop hanging at the tip of the burette, it's best to release it and then hope that the next drop doesn't come as fast. First, we're going to record the volume. So for me, that implies some transitions. The volume after the first increment addition it's 2.61 milliliters, and the pH is a 1.81. We can add another 2 milliliters or so. We can add another small increment. My new volume is 11.66 milliliters, and the pH is 2.48. This is a good point to slow down my addition a little bit. My new volume is 12.32 milliliters, and the pH is 2.58. The next volume is 17.01 milliliters, and the pH is 5.11. The volume here is 29.68 milliliters, and the pH is 7.16. Our solution definitely looks more bluish than green, so clearly we are in a more basic environment. The pH is 8.91. Let's add one more drop. And we have another color change that occurred as a result of a one-drop addition. This is definitely near the equivalence point. Our volume is 30.89 milliliters, and the pH is 9.35. Let's add one more drop. The volume is 30.99 milliliters, and the pH is 9.63. We can add a couple of drops. we have 31.41 milliliters. Our next volume is 34.89 milliliters, and the pH is 11.69. Our final volume measurement will be 47.61 milliliters at a pH of 12.21. With 3 measurements above 12, we can consider our titration complete. And once we do the graphing of this data set, hopefully we will be able to identify the 2 equivalence points and the 2 pKa values for this diprotic weak acid.